Great. Okay, good. Let's see. Today, what I'm going to do is I'm going to explore an area of the flow editor we haven't really spent much time on. And as always, this session focuses on a relatively small topic within the flow editor. And you guys are free to ask questions at any time. And then at the end of the session, we'll open it up for questions about not only this topic, but any other topics. So I've got a flow here. These are the names of all my drop-in training flows that I've used here. Two of you at least have been to many trainings, so you'll probably recognize some of these. Today I'm gonna go through a training that's called what do you do if you have 1,000 dots at the same location in 3D space? And as always, I'm going to do this from the edit mode rather than the present mode, just so we can see how these steps in this flow have been composed. Okay, so just like always here, this is I usually have this splash screen here, which shows that for my data set, these are the dots, and I put some queryability onto these dots in the form of this overlay pop-up. And in this particular case, I've got a data set. Let's say it's a very large data set, and I'm looking at the product type, which I have small, medium, large in my data set. So I'm going to say, this is medium, and the color of the product. So, just two arbitrary categorical types of variables that I'm going to be beating against each other here to see what they look like in the database. And so anyway, that's the data set. And what I've done purposely here is in my data set, I have 1,000 rows, okay? And this is a segment, let's say, of a much larger data set where I've got the same product type and the same color for all 1,000 of these rows in my database. So this might sound a little far-fetched, but if for very large data sets, when you look, especially if you're looking at categorical variables against each other here, like I've got color coming out in my depth axis, and I've got type going in my y-axis or my x-axis, my width axis here, it's not far-fetched that you'll have multiple occurrences at a particular value. So 1,000 is probably a little extreme, but what I wanted to do here is illustrate the point here. It's very common when you're displaying categorical variables in a scatter plot that there'll be multiple values at a particular point. Okay, so now here, this is how this would by default show up in a scatter plot. So I've got my scatter plot of value measure, which is 110, okay, and my color and my type here. So there's 1,000 occurrences at this data point. So this is how it would appear by default, okay? And the reason you just see one dot here is because all these dots are at exactly the same point, and they're all superimposed on each other, basically. So some observations I have about this is, first of all, this is very accurate. These are the values. It's extremely boring. You see one data point instead of 1,000, and it's potentially misleading. Okay, where you might think that, hey, there's one dot here, instead there's 1,000. So what we're going to do here is we're going to look at a section of the swarm definition here called additional dimensions. Excuse me, I just had to interrupt my dog here. These are additional dimensions here. Now, this is a section of the swarm definition that is kind of rich in what you can do with it. And we haven't spent much time on that in these training sessions yet. And this is probably training session number 1 of additional dimensions. But I'm going to take you through what a classic use of this is. So In this particular step here, very boring, 1,000 points, all 1,000 data points, all it's occurring at the same spot. Okay, so in looking at this additional dimensions here, we do have a feature here. First of all, we got several different things you can do here. You can make stacks of data. You can make columns, skyscrapers, random bubble clusters, Fibonacci circular clusters, violin charts. There's all sorts of things you can do here, and I'm going to show you about 4 or 5 of these today. The first one is bubble clusters. And what bubble clusters allows you to do, it allows you to explode all these individual data points that are all at the same point in space, okay? And just show you that there are actually multiple points there. I can query each of these points. Here's my 381st occurrence of this particular data value. Here is my 622nd. So you do them, if you do the counting here, there's 1,000 of these dots that are displayed here. So this is called random bubble clustering. And it's a very common use case when you're in this situation where you have multiple events or multiple occurrences of the same data point. Because it's one way that you can see that, hey, there's multiple things going on here. So if you look through our featured flows, you'll find places where this is used in this context. So in a normal context, a normal chart, there would be many points here, and there'd be many groups of these clusters of data. So that's called random bubble clusters, and it's one way of showing this. Now there are other ways of showing it that are a little bit more structured. So one way of showing it is in a stack. So if I go over here, what I've done here is I've chosen my additional dimension type to be a stack. So here I've got my height axis is my value. I've got my depth axis color and my width axis type. And what I've done is I've stacked the values of each of these points on top of each other. So stacks can very quickly run off the top of the chart. So this is going to be a little jumpy as I'm doing this in Zoom, but I can actually go up to the top of this stack and eventually see a big dot right in front of my camera. Okay. But one of the issues with stacks are once you start stacking dots, you've got the potential for them going way off camera. Okay. So even if I zoom way out on this, I still have trouble. There's so many dots here, so many occurrences that I still have trouble bringing that into my camera view. Okay, so what if we, instead of having a one-dimension stack here, how about if we have a two-dimension stack? Okay, well, we can do that. And what we do is we call that columns. Okay, so columns allows you to configure this dispersion of data around this single data point in a two-dimensional way. So it's a 2D rectangle of dots. And if I were to, let me just click on this particular dot right here in the lower left. Okay, I'm up. Okay, here we go, lower left, sequence number 1. This is the very first dot in my data set. And if I were to click on this very upper limit here, I'm just having trouble getting my camera. Okay, I've got I'm on the one right next to it, 999th. So as you're in your data set, what happens is when you have a column, these events at the location of the data, they get laid in one at a time. So here in the first row here, we got 1, 2, 3, 4, 5. Second row, 6, 7, 8, 9, 10. You can specify how many points per row over here. And you can specify the distance between the dots and how they're aligned with each other. There's several different things you can do here. And you know, if you have your own data set, you can play around with this a bit. So anyway, a column is a two-dimensional rectangular display of dots that occur at a particular point in 3D space. Okay, so even this one is pretty it's uncomfortably high off the graph. So what if we were to display this in a three-dimensional way around this point? That is called a skyscraper. So skyscraper, same kind of thing here. You specify how many points per row on the width axis. You can specify how many points per row on the depth axis. In this case, I did 5 points per row on my width axis. I'll zoom in on this a little bit so you can see it better. I did 8 points per row on my depth axis. Okay. And now what we've got here is since we're displaying these multiple occurrences at this point in space, I can really get this compact, and I can see it on the chart. So this is a common use case both on maps and on scatterplots. And in this case, I'm demoing the scatterplots. So like we did before, let's take a look at what the value of this dot is here. Okay, this is my 36 in my sequence. Okay, let's see what this one is in the far back here. Whoops, I think I'm in the second row there. Let me zoom in on this a little bit better so I just have a little bit better view of it. How about if I look at this dot here? This is my very first dot. Okay, this is the first one in the sequence. So my first one, second one, third, fourth, fifth, sixth, seventh, eighth. These will be laid into the skyscraper in this way. So I think if I understand this correctly, this should be my 1000th dot is right here, the one in the upper right front. Okay, that's 1000. Okay, so if you count all these dots, there are indeed 1000, and they're displayed in a three-dimensional way so that they can be seen comfortably in the context of a scatter plot. And once again, I'll say this is a very common use case on maps also. Okay, let's go to the next step here. Oh, we have one of these items here is called Fibonacci circular clusters. I don't know much about the theory of Fibonacci numbers or Fibonacci, whatever, but it's just yet another way of displaying the 1000 dots. And if I query these dots here, this is my 955th in the outer ring. If I go real close to the center here, this is my second dot. So the Fibonacci cluster is built in kind of a circular way, expanding outward around a point. So there might be some use case where this would be a particularly interesting or attractive way of displaying your data. Okay. Next step here. We also have a concept of micro offsets. So you can actually specify a little scatter plot at this data point. And in some of Michael's examples that he's presented in the past, he's done this on maps. So you have these little scatter plots that show the shapes of curves displayed at different points on maps. So what I did here, just to show that this indeed does work, what I did is for my scatter plot, I put up my localized scatter plot here. I made the width axis the sequence number, so it runs from 1 to 1000. I made my height offsets a sequence number also. So it's a easy 2D scatter plot where it's running from 1 to 1000 on each axis. Okay, so the takeaway here is at data points, you can also, using additional dimensions, you can actually fashion you can fashion little micro scatter plots there. So that could be a topic unto itself in one of these trainings, but I just wanted to introduce you to that concept. And then the final way, we've seen this before, the final way you can do this is through the use of categorized columns. It's a different way of, uses a different feature. It's not using additional dimensions here, but I'm using the categorized columns. And the categorized columns were originated to solve the same kind of issue. If you want to have an attractive way of displaying many points corresponding to a category, in this case, my medium category, you can do that using categorized columns. And just like what I've shown you before, if you look in the lower left-hand corner here, you're going to get your first record in your data set. Oops. Okay, There we go. So that's sequence number 1. That's this dot. And the very top right, this is your number. This is your 1000th record in your data set. So that's a quick trip through at least part of this item, which we call categorized or additional dimensions. Once again, the primary focus of what I've done here today is to show you that if you've got multiple occurrences at a particular point in 3D space using additional dimensions, you can show in a dispersed way all those data points, so they're all in front of you. And hopefully what I've been able to show here is by doing this in one dimension, 2 dimensions, 3 dimensions, it really makes a difference as to how many points you can easily show. So let me pause here and see if there are any questions on this particular topic of additional dimensions.
Hey, Bill, do you have a more elaborate example of the micro scatter plot that's like illustrated a little bit more in detail?
Yeah, actually, hey, Michael, to save me a little time, do you have one of your micro scatter plot illustrations that you put on maps that you could show us?
Sure. Let me try to pull one up here real quick.
Yeah, and Gary, I do have some others. Just take me a few seconds to find them. Hey, while Michael is doing that, let me show you one other flow here that I put together for some training. And I think what I'm going to do here is I'm going to squeeze it into this training here. This is an easy flow, and it also has to do with additional dimensions. So let me just take you through this, and then we'll come back to Michael's example where he shows a bunch of scatter plots on a map. So this one is, I'm going to take you through this one very quickly. This is my data. I have, I think it's 36 data points, and it's a kind of a classic data. I've got my product ID, my product type. I've got a value. I've got a country, city, latitude, longitude. It's kind of a typical data set, very small to illustrate what I want to illustrate here. So a classic way that we show data along in 3 dimensions in a time series is we have the date running along the width axis. We have values along the height axis. And in this case, I'm just showing you a 2D representation of this. So I haven't brought these other items out into their separate z-axis. I could if I wanted to, but here I just put them on a 2-dimensional scatter plot here. So I got 1, 2, 3, 4, 5, 6, about 9 different curves here. Okay. So if I'm using, if I'm defining my swarm here as being point per value, this is an alternative way of displaying that same data, where I've got the number of points here for my red product, that I've got displayed using additional dimensions, just like I showed you before. This is a columnar display, so it's a 2D column of dots. So this shows the relative volumes of my red product, my orange product, my purple, yellow, another orangish kind of product, my green product. So this is a common way of displaying relative numbers or relative values using point per value and then displaying them in charts like this. Okay. The next item I wanted to go to here is I'm using skyscrapers to accomplish the same thing. So here what I've done is I've defined, this is now a 3-dimensional array of dots, and I've defined my skyscraper in this particular case to be 6 dots along the width axis and 2 dots along the y-axis or along the depth axis. So here, just like I showed you earlier, the point here is to get this so the display is more compressed on the chart, so it fits more easily into the boundaries of the chart. This next item was, this was my initial try at using stacks. And I ran into the same problem I ran into in my earlier discussion. By the time you stack these things on top of each other, they tend to run off the top of the chart. So the way I got around that, notice in my stack here, or in my swarm definition here, I'm using point per value, and I'm using each point represents a value of 1. So if this value of this point was 30, I'm showing 30 dots. Okay. So what I can do here, if I wanted to use this stacking type rather than a column or a skyscraper, if I modify this, each point equals a certain number of values. Like if I change this from 1 to 5, let's say, it's going to bring down this chart by a factor of 5, the height of it. So in my next swarm here, I've done that. I've got point equals 5, and now my stack fits more nicely onto my chart. So this is a variation of what I showed you in the first flow, and just shows that when you use point per value in conjunction with additional dimensions, you can kind of get these charts so that they fit nicely into the boundaries of your scatter plot. So Michael, let's see, are you ready to switch over to show Gary or show us scatter plots on maps?
Yep. Yeah,
Okay,
I can.
I'm going to stop sharing right here. Okay.
All right. Cool. So let me just share my full screen here. And all right. So this was a prior example, at least from a prior training, called stacking dots on a map. I'm showing this because it's less of a scatter plot and more of a stack. But the concept still remains the same. And I'll show another sort of live example here in just a moment. But I just wanted to reference this point just so you have another video that you could possibly look at that goes into a little greater depth on some of what you can do for stacking dots. And this technique has been used for pretty much all of these, or for a little bit there, I was creating videos on basically movement of people from one county to another. And so that's all done through quote unquote stacking dots on a map, that you're stacking them up and then you're moving them around and watching that transition. And so wanted to point that out, but then let me bring up a different example, which is this life expectancy for training visualization. And this one, what's nice about this visualization is that this actually uses the demo media data sets. So this is using the life expectancy data from our data sets. So from our library. And so you can basically recreate the exact same thing using that data set, where all we're looking at is life expectancy for a number of different countries and year combinations. And so it goes through a bunch of different steps here. This is looking at just life expectancy, I believe, in just 2018, and then looking at these dots in sort of a multitude of different ways to look at the different ways to view life expectancy. One of which is just looking at 2018, but then the other is to take that singular data points and actually look at things over time. And so these are sort of the graphs that you typically would see. And this is just a linear graph going from 1901 to 2018 to see how life expectancy has increased so dramatically across the world. And next, I believe the step is to actually create these graphs, which is the actual, average life expectancy, and then each life expectancy for the different countries around the world. And then the matter of basically taking that and starting to overlay it onto the globe. On this very last step, the technique that was used was not micro offsets, but instead the size of the dot. So to just interpret this last graph just a second, it's that the distance away from the map is the year, and the size of the dot is the life expectancy. Now, I don't know if this is the most meaningful way to represent it. I think we've experimented with others, but let me just unlock this one real quick and save one more copy. Actually, I'll just keep going on this one. And so I'll add a step because just to show a different way of representing this information that is more into the micro offsets, which is more of the what we're trying to do here. If I go into additional dimensions, you'll see the height offset is the year. And what I could do is actually, instead of making the height offset the year, I could make the width offset the year. And so this would be the width of the offset, and then the height, I could make that instead the life expectancy. And I could make this much smaller here, make this like 0.1. And so now we'll start to see those same curves overlaid onto the map itself. Now you'll notice that it looks a little odd on a globe, where you can't draw straight lines on a globe here. And so one way to quickly alter that would be to make that map not a sphere, but to use a different projection. And so if I take this swarm and apply it instead to map this other map, now I'll start to make a little more sense in terms of taking a scatter plot and applying it against or onto a map itself. And I'm going to make this a little bigger here so we can actually start to see some of the distinctions, as well as, let me rotate this back. So now we're basically creating those same lines that we saw in the prior step, but we're doing so where the actual location of it is being offset by its region on a map. So this is all done with additional dimensions. If I were to turn off additional dimensions, just to maybe bring home the point here, if I were to just basically turn off all these guys, you'll see that indeed they're all just on a single dot on a single point on the map. And that's basically what Bill was documenting. It's like, okay, if you were just to take all the dots and use all the parameters, they're just all in the same spot. Now from there, now that we know where they are, now you can apply whatever transformations to create mini scatter plots or size differences, things like that, to be able to visualize. So that is the intent here. And yeah, definitely a lot more we could do to this, but this is just one example that helps show. Sorry, I should turn off that. Yeah. So yeah, any questions on this example? And I can try to find some other examples as well. This was sort of the one that came to mind first for me, at least.
Yeah, this is the one that I had in mind too. I think you have another version that I've seen where the curves are a bit more attractive on each data point. The dots are smaller, and I think they're connected together. And yeah, something like that. Yeah. So anyway, Gary, this is an example of the kind of thing you I believe you're asking about.
Sorry, it wasn't me who asked, but
I'm sorry. Okay.
It's all right. Bill, this is how I asked this question. So Michael, can you just point out where you associated the coordinates on the map with the specific scatter plot for?
Yes, absolutely. So here in the definition for the swarm, and what you'll see here is just map to regions. So map to regions is using the map that was defined, map 2, using the region column called country to basically say, this is where the center of the country should be. and where those dots should be located. So that's essentially how it's being put into position. If I were to, change this to something that doesn't make sense, then you'll see all the dots sort of go to one location on the map because it doesn't know where to go. And so by having the country as the main mechanic here, that's how we're able to place it on the map. Now, another thing you could do besides map to regions is map to coordinates, where you actually use the latitude and longitude in the data set. But this data set does not have latitude, longitude information in it, hence why we're not using it. So it's the map to regions using map to region country. So that is essentially how it's set up. And then all of the micro offsets are being defined in the additional dimensions section.
Okay, so for map to regions, without looking at the data, I'm assuming the country column is like a text column that shows the country name, and then you do some kind of string. You just match the string basically. It's Japan, and then you have your map has the location of Japan is Pete. We're using the name, so that's how you
right.
map. Okay.
That's right. Yeah, and so you can actually see that it's actually in the map definition itself. So if you click onto the map, you'll see here the different parameters. And up here, you have a button that says Get Available Regions. If I click Get Available Regions, what you'll see come up, if it comes up here.
Yeah, I think is that downloaded, Michael?
Yes. So what it does is it downloads basically the different aliases that could be used to match the region to the location on the map. And so these are the different things that could be used. So you'll see Indonesia here, and these are different ways to spell it. And that is essentially how it can take the region column from your data set and matched up to the map itself. And so we're not going to dive into the deep aspects here, but that's essentially what you can do when you upload your own topo JSON file to define the map. But here is where you can basically define different regions based on the map that you have to link them up. So that's one way to at least check to see how it's being lined up in case things are not matching, or if you're adding in your own.
Okay, but you guys have some built-in maps for the world and for United States, or with regions already defined like this, right?
That's right. Yes.
Cool. Thank you.
Yeah, and that's what we're showing you here is how the regions are defined for this equirectangular map. So your responsibility in your data sets are to make sure that the spelling of the countries match what's expected by the map.
That's right.
Yeah. Yeah, it looks like there are different options too. You can completely spell it out, China, or spell CN, and either one would work.
Right, right.
Cool, thanks.
Yeah.
And then I saw, Stephen, your question on counties for the US on the globe. So I believe, if I'm not mistaken here, let me share my screen again. So so for county data, let me turn this guy off, and I'm going to create a new map. And so this map will be the US. So we have the US map that's, excuse me. So we do have a US map. It is not on a county by county level. This is just the overall US. So we don't have the county map here. And if I click get available regions, you'll see that the regions are just the states. That's essentially all that's represented here. But we do have some examples where we do use county. And we did that by uploading a topo JSON file. Now, one thing that I want to make sure we have, or everyone has access to, is inside of our demo media folder that everyone has access to. We do have a few additional topo JSON files, one of which is USA counties, as well as zip codes, counties with a FIPS ID associated with it. And so if I were to use one of these files instead, that is one way I can actually get.
Yeah, and I think those are not on a globe, but I think it's a flat map.
It is a flat map, but the thing I want to show is actually you can bring it over.
Yep.
And put it onto a sphere. So this is county information. You'll see it's on a flat map here. But if I change the projection, I can change the projection to go onto a sphere. And then you will see the world, and then just whatever geography you have loaded on a map, and everything else is blank. So this is it reminds me of this old piece of artwork we used to have in our house that was the United States according to a New Yorker, where it was, New York, Long Island on most of the photo, and then there was like the middle of the country, and then there was California, and then there was Japan. It was just like everything was small in comparison. So I think that's at least what it reminds me of. So yeah, I actually really like putting it on the map still, because one of the advantages of showing maps this way is that automatically when you stack the dots, they space out a bit, making it easier to read and decipher. So that's my take on that. So anyways, hopefully that's helpful to see, one, the demo media folder, which I want to make sure everyone has access to, and I'm going to put the link to that here in the chat window for everybody.
So you just change the projection to sphere. You want to have the map lay over the globe.
Sorry, say that one more time.
So you just change the projection to sphere.
That's right. Yes. Okay. That's right. Yep. Cool. And so that link to the demo media folder is in the chat window.
Yeah, and I think that is probably referenced somewhere in our help center. I'll go looking for that. If it's not referenced in our help center and findable easily, we'll make that so that's the case. Yeah. So any other questions on any topic whatsoever?
So I have just joined for the first time. We're a small boutique branding transformation company out of London. A lot of these things, I understand them intuitively, but this is a few steps ahead of where I am. So I just wonder if it's okay if I just show up every week until I begin to make sense of myself, or can you recommend a more basic training online that you already may have in the can so I can catch up?
Yeah. Yeah, there's a variety of ways. We have posted on our help center our links to our training videos, as well as many articles that we posted on our help center. There's probably hundreds of help assets there. Also, this is I think this is training session approximately number 30 of these training sessions. We've been doing it for about 15 weeks or so, twice a week. And all the prior postings from these drop-in trainings, which are usually focused on one kind of tight topic, those are also all available to you. So there's a huge number of things you can view, Gary, to kind of catch up. You're certainly welcome to join us anytime. Both Stephen and Hal are veterans of these sessions. They've been on several of the sessions, many of the sessions with us. So that, that's a quick answer to your question. There's a lot of stuff out there.
Fantastic. And thank you for putting up with a newbie. I appreciate it.
No problem. Newbies are always welcome.
Agreed. Yeah, no, we'd love to have
it's
you.
not possible for you to test Bill and Michael's patience more than I have. So they're happy to have them.
No, it's actually awesome seeing you guys here on a more regular basis, and yeah, that's what it's here for. So do take advantage of it. We'll be here. So yeah.
Thank you.
Of course.
So tomorrow's, what's your session for tomorrow, Michael?
It is hosting live meetings in Flow, and specifically we'll dive into how to host a meeting in virtual reality, where if you have a virtual reality headset, you can join the meeting from headsets and see other participants, etc. So we'll be diving into that tomorrow.
Okay, let's see. One final chance for any final question. Okay, I guess that's it for today. Hey, thanks guys for joining us on this session today, and we'll see you on email and in some future session.
Thank you very much, guys. Take
Thank
care.
you.
Okay, thanks.
Thank you.
Everybody,
Bye.
Bye-bye.
Tomorrow.